Hi there, my name is Minz Harlabidis, and in this video, we will talk about the square of a sum. So basically, we need square of a sum. So let's imagine ourselves having a sum, let's call it A plus B, and we need to calculate a formula that will allow us to determine that sum. Now, we'll do the whole process through an inquiry I keep doing in my classes. The first question is, what do you imagine A plus B squared is equal to? There is always one student, at least one student, that might say that, I know, sir, A plus B squared is equal to A squared plus B squared. Then we go and see all of us together why this is wrong. In this case, we introduce the concept of counterexample. We can see together as well that if that was true, if indeed A plus B and all that squared is equal to A squared plus B squared, then it would be true for any random combination of numbers we can simply imagine. So it could also be true for the case of 3 plus 2 squared. So if that was true, then 3 plus 2 squared would have also been equal to 3 squared plus 2 squared. But of course, we all understand that 3 plus 2 is 5, and 5 squared is 25, while on the right side we have 9, which is the result of 3 squared, plus 4, which is the result of 2 squared, and 9 plus 4 equals 13. So we managed to prove that 25 equals 13, which is obviously not. Why is this wrong? Because we assumed that 3 plus 2 squared is equal to 3 squared plus 2 squared, so this assumption was wrong. This is wrong. Okay, so what is A plus B squared then? We are still need to find this expansion. We need to think of the powers. What is even x squared equal to? X squared means x times x. Similarly, y squared is y times y. 10 squared is 10 times 10. Remember, at this point, we keep saying that, whether you know me in person or through these videos, I keep saying that math is not about numbers. Math is about symbols. So if x squared is equal to x times x, then I guess that this box squared should be equal to box times box. This heart squared should also be equal to heart times heart. In general, anything squared should simply be anything times anything. Therefore, even the A plus B squared should be the same as A plus B times A plus B. So now we have something to work with, because we know that in order to do the expansion of this, the A plus B plus A plus B, it's something we call double distribution. We just need to multiply every single term of the first bracket with every single term of the second bracket. So let's do it together. A times A should be A squared. A times B, it's AB. B times A, it's BA. And then B times B, it's B squared. We suddenly notice that whether we say A times B or B times A, this is basically commutative property. It's the same. The commutative property states that when we multiply two numbers, the order through which we do that does not alter the result at all. 2 times 3, it's 3 times 2. 5 times 6 is always equal to 6 times 5. Therefore, A times B should be equal to B times A as well. So, I'm going to rewrite this as A squared plus AB plus AB again plus B squared. And finally, I'm going to group these two. A squared plus 2AB plus B squared. And then there you have it. You just proved that A plus B squared is equal to A squared plus 2AB plus B squared. And this is called identity because this statement here, A plus B and all that squared equal to A squared plus 2AB plus B squared, is always true for any combination of expressions A and B. Let's see how we can use that properly. Let me write here the formula. A squared plus 2 times A times B plus B squared. And let's work together some examples. Let's begin with x plus 3 squared. All that we have to do, you have to understand that what's the meaning of this identity? The meaning is that it can save us some time. Instead of doing again that x plus 3 squared is equal to x plus 3 times x plus 3, we can jump directly to the result. In order to do that successfully, we just need to understand who plays the role of A. Obviously, x should play the role of A, and who plays the role of B. Obviously, 3 plays that role. Based on the expansion, we knew that at first we need to write A squared. In our case, that should be x squared plus 2, there's always a 2, times A, which is x in this case, times B, which is 3, plus B squared, 3 squared. So now it's time to do some simplifications. X squared is x squared plus 2 times x times 3. How do we multiply expressions? Numbers together. 2 times 3 is 6, and then x plus 3 squared is equal to 9. Another example. W plus 2 and all that squared. Here, obviously, the role of A is played by W, while the role of B is played by 2. The identity starts with A squared. In this case, it's W squared plus 2 times W times 2 plus 2 squared. W squared stays like that, plus 2 times W times 2 should be 4W plus 4. Next one. 1 plus K squared. Again, A is played by 1, while K plays the role of B. The expansion of this identity starts with A squared, so 1 squared plus 2 times 1 times K plus K squared. 1 squared is 1, 2 times 1, 2 times K plus 2K plus K squared. Let's increase the level of difficulty a bit. And let's change color for that. 2x plus 5 and all that squared. In this case, again, we have something times something else and all that squared. So A is represented by 2x, by the entire 2x, while B is represented by 5. We know that the expansion starts with A squared, so it should be 2x and all that squared, plus 2 times 2x times 5, plus 5 squared. 2x squared, it's this property that states that a times b and all that to the power of n is a to the power of n times b to the power of n. So 2x squared should be 4x squared plus 2 times 2, 4 times 5, 20x plus 25. Another one, 6 plus 3x squared. Here, 6 is represented, it is representing A, and the entire 3x represents B. The expansion starts with A squared, so 6 squared, plus 2 times A, which is 6, times B, which is 3x, plus B squared, so plus 3x and all that squared. So 6 squared is 36, plus 2 times 6, it's 12. Multiplied by 3, it's 36x plus 9x squared. Let's make them a bit harder again, and let's change color again. 2x plus 5y and all that squared. In this case, A is being represented by 2x and B is being represented by the entire 5y. The expansion starts with A squared, so it should be 2x and all that squared, plus 2ab, so for this case it should be 2 times 2x times 5y, plus 5y squared, which is the b squared. 2x and all that squared is equal to 4x squared plus 2 times 2, it's 4, times 5, it's 20xy plus 5y and all that squared is 25y squared. Let's see another one. 5x cubed plus 2x squared and all that squared is A is being represented by the entire 5x cubed, so that should be A. B is being represented by 2x squared. So to initiate this expansion, I should do A squared, which is 5x cubed squared, plus 2ab, so 2 times 5x cubed times 2x squared, plus b squared, so 2x squared and all that squared. 5x cubed squared, that would be equal to 25 times x to the power of 6, because I used, let me write that property somewhere here, I used, sorry, let me write that properly here, I use this thing, a to the power of n, and all that to the power of m is a n times m, plus, sorry, wrong color, this one, plus 2 times 5, 10, times 2 is 20, x cubed multiplied by x squared, there's another property hidden, which is this, an times am, you keep the same base and add the exponents. So x cubed multiplied by x squared, it should be x to the power of 5 plus 4. Normally it would have been x squared and all that squared, so it should be x to the power of 4. So you see that even the last one seems, and it is, harder than the original ones, we still follow the same pattern. And this video is simply on that, following patterns. From now on, you should keep in mind that whenever you see something times something else squared, a plus b squared, that by default is equal to a squared plus 2ab plus b squared. And remember, as always, that math in general works with symbols. So even if we had something like that, a kid plus a heart squared, we should still have done that kid squared plus 2 times that kid multiplied by the heart plus the heart squared. That is all. I hope this video make things a bit easier. Remember that it takes practice. All you have to do is practice more and more with more exercises. In case you still have any issues or facing any difficulties, please don't be shy. Let me know of them by leaving a comment. As always, thank you for watching and thank you for your time.